Hello everyone, welcome to this new lecture in the Python programming course. In this particular lecture, we will learn about source code and object code, and we'll see their comparison and also go over several details with respect to the same. So let's get started. Let's see what all we'll be covering as part of this lecture. First of all, we will see what exactly is a programming language. Next up, we will see source code, and we'll also learn about object code. Under object code, we will learn about machine code and about bytecode. And finally, we will go over the differences between machine code and bytecode, and eventually we will also learn about the differences between source code and object code. So here we saw what all we'll be covering throughout this lecture. Now let's see what exactly is a programming language. Programming language is a formal way or a formal language to communicate with computers. Basically, we need a medium or a way to instruct computers in order to perform any actions. Well, programming languages are that medium, which enable us to instruct computers for any kind of task. There are mainly two types of programming languages. First of all, we have the high-level programming language, and then we have low-level programming language. Now that we have seen the major types of programming languages, let's see a bit more on each one of them. First of all, let's see what is a high-level programming language. A high-level language is the one which uses English and mathematical symbols as the instructions. Some examples include Java, C, C++, Python, JavaScript, and so on and so forth. So we understood what exactly do we mean by a high-level language. Now let's see what is a low-level language. A low-level language is something which is machine-oriented. It is described as being close to the hardware. In order to understand a low-level language, one requires good understanding of the computer's internal architecture. Now that we have understood what exactly do we mean by a low-level language, let's move on further. Let's see what exactly is a source code. A source code is basically human-readable instructions that a human or a programmer writes. The source code consists of programming statements that are created by a programmer with a text editor or a visual programming tool, and then saved in a file. Simply put, this is the code which is written in a programming language such as Java, Python, C, C++, JavaScript, and so on and so forth. We learned a similar thing previously in the programming language part, and specifically under high-level language. So usually when people talk about programming languages, what they are referring to is languages which are used to write source code. So we understood what we mean by a source code. Now let's see what exactly is an object code. An object code is a code which is generated from the source code using a translator software. Basically, a source code is fed as an input to a translator software which produces an object code as its output. An object code mainly consists of machine code, bytecode, or possibly both. The object code contains a sequence of instructions that the machine can understand, but that is difficult for a human to read or modify. Why do we need an object code? Well, machines do not understand source code in its raw form, or let's say plain text, whether it be English or a mathematical instruction. Machine, or in this case computers, process information using electric signals. If I put that in simplified form, binary notation is something that machines can use to handle information. Thus a code closer to a binary notation, or which is actually in binary form, will be easier for a computer to understand. Machines can relate more to a language which is closer to the way it functions. Now that we have understood about object code and its need, let's move on further. Let's see what exactly is a machine code. Previously, under object code, we read that it comprises of machine code, bytecode, or both. Well, machine code is the only code that a machine understands, and it doesn't need any further translation in order to be executed or processed by the computer. Earlier, under object code part, we read that object code is generated from source code via a translator software. Machine code is the final form which the machine processes, and when I say final, I mean that it does not need any further translation in order to be processed by the machine or the computer. Well, why I am focusing on the word final is because there is an intermediate form of code which we will learn about shortly. Also, machine code is in binary notation, which is easily understandable by the computers, as computers use binary notation in order to execute or process information. So we understood in details what exactly is a machine code and how it uses binary notation in order to interact with the computers. Now let's see what exactly is a bytecode. In the previous part, I talked about an intermediate form of code, and I said we'll be learning about that shortly. Well, bytecode is that intermediate form of code. It is an intermediate code between the source code and the final machine code. Now, being an intermediate code and not the final machine code, bytecode is processed by another machine called virtual machine before it is executed by the computer. Virtual machines are virtual computing systems that imitate a computer. Their implementations may involve specialized hardware, software, or a combination of both. There are system-based virtual machines, and then there are process-based virtual machines. System-based virtual machines provide a substitute for a real computer, and they have functionality needed to execute an entire operating system. Whereas, process-based virtual machines are designed to execute computer programs in a platform-independent environment. From the context of this course, we are focusing on process-based virtual machines. As I explained about the virtual machines, they enable a computer program to be platform-independent, and they are the reason why a bytecode is known as a portable code. Well, this is a very important feature which enables our code or program to not be tied to only one machine or platform type, but enables it to run on any machine or platform. For example, let's say we have a code where we declare some variables or references and want to do a comparison between the values of those variables. Now this is how the same code will look like in bytecode, where keywords like iconst, istore, and iload are used for storage of values, assignment of values to a variable, and retrieval of values from a variable in the memory. Keywords like if_icmpgt can be used for comparison operation between the variables, and based on the decision, we can decide to go to another instruction in the program. In this particular case, it is asking the program to go to instruction number 19 based on the result of this comparison. So, we saw what exactly is bytecode and how it helps in achieving platform independence with the help of virtual machine. Let's move on further. Now that we have learned all those concepts, let's go over some differences between machine code and bytecode. As we saw earlier, machine code is in the form of binary instructions that are directly understandable by the CPU or the computer, whereas bytecode is in the form of binary, hexadecimal, or macro instructions like new, add, swap, load, etc., which are not directly understandable by the CPU or the computer. Well, just to specify a bit on macros, macros are single instructions or keywords which have a set of instructions implemented behind the scenes and which help us to achieve a particular task. For example, add can be used to provide the sum of the inputs, and we don't need to worry about how it's implemented behind the scenes. Machine code is a low-level code. We can understand it as a code that is native to machines or at a level that machines can directly understand and execute. Bytecode, on the other hand, are intermediate-level code. They are an intermediate between source code and machine code and need further translation to be executed by the computer. Machine code is not platform independent. That is, they are native or specific to the platform for which they are designed to run on. Whereas, bytecode provides the platform independence feature and enable the program to run on any platform instead of a specific one. Being native to the machine and being the final code, machine code is directly executed by the CPU and doesn't need any further translation. Bytecode, on the other hand, needs to be executed by a virtual machine and the output then can be executed by the CPU. So here we went over the differences between machine code and bytecode. Now finally, let's go over the differences between source code and object code. Source code, as we learned earlier, is the one which is written by a human or a programmer using a text editor or a visual programming tool. Object code, on the other hand, is the one which is generated by a compiler or an interpreter from a source code. We had briefly covered compilers and interpreters in the previous lecture, and we will cover a bit more on them in the upcoming lecture. Source code is a high-level code, and this is easily modifiable by humans. Object codes are low-level codes, which are not easily modifiable by humans. Being high-level, source code is understandable by humans. However, object code is the one which is not easily understandable by humans. Source code is plain text and is written using a high-level programming language such as Java, Python, C, etc. Object code is translated from source code and it consists of binary and other formats like hexadecimal or macros. Source code are less closer to machines and more closer to humans as they are written by humans, whereas object code is more aligned towards machine as they are a result of machine processing. So we learned about the differences between source code and object code, and that will be all for this lecture. Thank you.